CircuitPythonistas, it's Prof G, and in this lesson we'll learn about CircuitPython libraries and how they can extend what we can do in Python. We'll use some example code, and we'll install a tool called CircUp, which can be a huge help in managing libraries on our board. Now this does require a bit of setup, which can be frustrating if you just want to jump into coding, but trust me, this is a useful thing to learn, and it's going to remove a lot of frustration that earlier students have experienced. Now while I'm going to demonstrate how to get CircUp running on a Raspberry Pi Pico series board, you should find that CircUp works identically with any CircuitPython board. So even though you could use any of the hundreds of boards that run CircuitPython, the setup and use should be entirely the same. Now we'll also demonstrate how to get some simple code up and working on the Pico after the install, just so that we can test things out. I'm going to show how we can install some sample code to flash a rainbow pattern with a NeoPixel light strip. If you don't have one of these, the CircUp install procedure should be the same. Just skip the sample code or try it out with some different code. And if you're not using a Pico but you still have one of these light strips, I'll point out where you can make two simple modifications to the code so that it runs on most other boards. Now if you're brand new and you haven't set up your board to run CircuitPython yet, start with the first video in the playlist for your board. And if you share my work with others, thanks for helping out. Now let's talk libraries. So here's the scoop. Standard Python doesn't know how to work with NeoPixel lights, sensors, motors, and the other types of hardware that we use in this course. But libraries allow us to extend the Python programming language. And if it helps, you can think of libraries as extending the vocabulary of Python so that it has more knowledge and it can do more stuff. Now, just a quick note on terms. You'll hear the terms module and library used. In Python, the term module technically refers to one file that can extend Python's capabilities, while libraries refer to a collection of modules. But in practice, you're going to hear people use these terms interchangeably all the time. Also, sometimes you'll hear folks talk about CircuitPython's built-in modules. These are capabilities that are built into the basic CircuitPython. You got those automatically when you installed the UF2 file in the prior lesson setting up CircuitPython. And for built-in modules, we don't need to import anything besides the basic CircuitPython. But CircUp is all about going beyond the built-in modules and adding new capabilities. Now, engineers at the Adafruit Corporation have developed and maintained hundreds of open source libraries for CircuitPython. CircuitPython works with a ton of additional hardware, but the libraries are so big that all of them wouldn't fit on most boards. The memory on most microcontrollers is pretty small. But you can visit CircuitPython.org and download all of the libraries, plus hundreds of sample code examples showing you how to use them. Also, in addition to the hundreds of libraries engineers at Adafruit have created and maintained, there are hundreds more developed and maintained by volunteers in something called the community library. So you drag a library on your board, and you extend what CircuitPython can do, like work with lights, play sounds, recognize sensors. Libraries are great. They mean there's an almost infinite amount of expansion that can be added to the CircuitPython language, but adding and upgrading library files manually can be a real pain. It's error-prone, files you might need aren't obvious, it can be tough to find what you need among the hundreds of files that are available, and working with libraries has been a frustration for lots of my former students. But fortunately, there's a great utility that we can use that will make working with libraries much easier, and it's called CircUp. You use CircUp to install library files on your board, and it will also upgrade any files if new versions are available, and it'll even look at your Python code and install any additional files that code needs to run. Shout out to Nicholas Tollervey, CircUp's creator. It's free, open source, and now lives on the Adafruit GitHub pages. So first up, I want to show you how we can use CircUp to install libraries needed by the code on our board. So we're going to put some Adafruit example code on our board to see how this works. So follow along with me. We're going to find and download the latest library bundle. I'll show you how you can find example code. We'll explore the examples folder, and we'll load some example code on our board. We'll note that the code does not run because we don't have any libraries installed on our board yet, so we'll install CircUp, which requires a few steps, but it's definitely worth it, and we'll only have to do those once. And then we'll use CircUp to look at our example code and automatically install all the libraries we need to our board's lib folder. Let's start by downloading the libraries bundle so that we can get some example code and put an example on our board. Now, to make sure you get the same results as me, my students probably are using boards that have been used by other students. Let's start with an empty libraries folder. Plug in your board, it'll show up on your computer as CircuitPy, go into the lib folder, and delete anything that's in there. Now, once again, let's open a browser and return to CircuitPython.org. And this time we're going to click on Libraries in the tab at the top and scroll down until you find the Bundles section, and you want to download the bundle that matches the version of Python that you just installed on your board. Now, my version was a version of Python 9, so I'm going to click on this purple button for bundle version 9.x. If you've got a higher number and installed a higher number, use that. Your version will probably save to your downloads folder, but I configured my browser to allow me to save it to the desktop. Then find the folder that you just downloaded. It should have a name something like Adafruit-CircuitPython-bundle. If it's still a .zip file, double-click that to unzip it. Then open the folder up and let's take a look at what's inside. Now we see a few things in here. First, there are examples. Let's open up that folder, and there are a lot of examples. The libraries are usually named with the name of the hardware that they enable. Now, unfortunately, most products are named by hardware engineers, not marketers, so they have terrible alphanumeric names. But if we search through this, you can find a folder named NeoPixel. That's Adafruit's brand name for individually addressable lights. And on the Mac, you can click on the column and just type the word NeoPixel, and you should jump to that spot in the list. Now, this folder here contains a bunch of example code for working with NeoPixel lights. Some boards have built-in NeoPixels, like the Circuit Playground Bluefruit my students used earlier in this course. There are no built-in lights for the Raspberry Pi Pico, which is why I added a NeoPixel light strip. And I'm going to turn on the column format in the Finder. This shows how we got here from the Bundles folder to the Examples folder, and then to the NeoPixels folder. And I'll adjust the column so that you can see things a bit better. And now inside this NeoPixel folder, the file that I want to use is NeoPixel_rainbow_simpletest.py. And if I click this file, I can see a preview of the code in the rightmost column. It doesn't give me a whole lot of information, but this example will simply light up the number of lights that we specify at the location that we specify where they're connected to in an animated rainbow pattern. And who doesn't like that? So let's give it a try. Now, as stated, CircuitPython will try to execute any file on your CircuitPy board that's named code.py. Now, we don't have to type a run command or anything, just plug the board in or reset it and code.py will run again. It doesn't even have to be connected to a computer. You just have to power it, so you can plug it into a standard USB port or even run it off of a mobile phone battery. Now, our CircuitPy board may already have a code.py file in there, but if it does, that's okay because we're going to replace it. And before I do this, since this code works with NeoPixel lights and since all my students have one of these NeoPixel strips, I'm going to set up my Pico board with my NeoPixel strip. Now, while my board isn't plugged into a USB cable, I've plugged my Pico into a breadboard. Pro tip for Pico users, the Pico pins aren't labeled, but I'm using this breadboard from Monk Makes that has the Pico pin labels right on the board. Highly recommended. I have this for all my students. And if you need a reference for your Pico pins, you can find that online at pico.pinout.xyz. And I have 3 pin jumper wires plugged into 3 of these columns. My red or power wire is plugged into V-bus. That's in the lower far right in this orientation. My black wire is ground, and that can go into any ground. I'm using the 3rd one from the lower left. And my signal wire is colored white. I'm using pin GP16. That's all the way in the lower left. Now, if you got another board, just remember which pin you're using for your signal, because we'll need that when we modify our code. And then you can clip the 3 clips on your NeoPixel strip to the 3 wires, black ground, red power, and white signal, and then you can plug your board into the USB cable so that it's connected to your computer. And you can tell that you're getting power because there'll be a green light that flashes on the board. Now let's get back to looking at our lib folder. In the NeoPixels folder and the examples folder, I'm going to grab my NeoPixel_rainbow_simpletest.py file. Make sure you select the right one. There are a couple of other files that have similar names. And I'm going to drag this right onto my CircuitPy volume so it copies onto my board. Make sure it's at the base level of your board and not inside of your lib folder. So I opened up CircuitPy and I can see I copied the file in there. If you have a reason to save this code.py file, you can drag it onto your computer as a backup. If not, just throw it in the trash like I'm doing. And I'll rename the file I just copied over so that it's now called code.py, all lowercase. So now I've got the example file on my board. It has that code.py name, so it should run, but my code doesn't do anything yet. Now, one thing we need to do is modify our code to tell it how many lights we have and the location where those lights are connected to. So to do this, we'll quickly get into the code editor at circuitpython.code. And before we can do that, we want to make sure that our board is plugged in and CircuitPy shows up on our desktop. It does. That's what we're seeing here. So to do this, we'll quickly get into the code editor at circuitpython.org. Follow me. First, if you have a Mac, you can't use Safari. You have to use Chrome or a Chromium-based browser. So we can head to this URL, code.circuitpython.org, and now I want to connect to my board. We're connecting via a USB cable, so click that, and we need to select our device, click on the purple button, then look for the name that has the phrase USB modem inside of it. That's your board. Here's mine. Click that, click connect. The purple snake will swirl for a couple of seconds, and we're connected to our board. Now we just want to confirm that it's called CircuitPy. It is, so click on Use CircuitPy, and then let's open and modify our code.py file. So click the Open button, and there are a bunch of files in here. This is an unfriendly dialog box. It's showing you actually visible and invisible files that are on your CircuitPy board. Ignore everything and just find and click the one that's named code.py. That's our code. Double click it or select it and click Open. And if you're brand new here, this likely doesn't mean anything to you right now, but I'll talk you through the changes to get this working. First, there's a line here with a value named NumPixels, and there's a comment after the hashtag here that says update this to match the number of LEDs. Well, my NeoPixel strip has 30 lights on it, so I'm going to change this number to 30. And the only other value that I need to change is the one named pin. This is the name of the pin on our board that's connected to the NeoPixel lights. You've got 3 wires. I connected by signal wire. For me, that was a white wire to GP16. So I'm going to replace board.A3 with board.GP16. That's with capital letters GP, no space in between. If you have a different board with different pin names, this is where you put in the proper pin names. And if you don't know how to do that, check the Adafruit Learn Guide for your board. And I'll click on the Save and Run button. Each time you save, the purple snake will swirl for about 5 seconds as it tries to run your code, and this side window pane opens up, and the terminal shows the results of executing code on my board. And we'll learn more about these statements later, but this line here says import error, no module named NeoPixel. Now again, if you're new, you don't know a lot about this yet, but in my code over here on the left-hand side, I have a line that says import NeoPixel. That means this code is going to try to import the NeoPixel library to extend its vocabulary to work with NeoPixel lights, and our code is expecting to find that library in the LIB folder on our board. But remember, earlier on, we made sure we have nothing inside of our LIB folder. It's empty. But it's even trickier because the NeoPixel library might also use some other libraries that aren't explicitly mentioned in this import statement. I've put an example of what will eventually be installed in here. There's an additional library called Adafruit_PixelBuff that isn't mentioned at all in our code. But CircUp has got your back. We'll see that after we install CircUp, all we'll need to do is simply type in a single command, and CircUp will identify all the libraries we need, find them stored on the internet, and load them up onto our board. It's awesome. Now, if you have the list of libraries that you need, you can drag them over one by one from that LIB folder that's inside the bundle that we just downloaded, but that requires that you know which libraries you need, what their names are, and you have to drag them all over one by one. It's time-consuming, lots of errors can occur. That's why we use CircUp. It takes care of all of this. So let's install CircUp so we don't have to worry about the manual library install. Now, there are a few things we need to make sure that your computer, not your board, has installed before we can install CircUp. First, your computer needs a version of Python. I believe it's version 3.8 or greater. We also need Git installed. Git is a tool that your computer uses for version control. We don't need to know about the specifics of Git to use CircUp, but we do need to have it on our computers, and we need to install something called pip. Pip installs and manages software packages. We don't need to know how to use pip, but we do need it for CircUp. Now, there is a detailed Learn Guide online that Melissa LeBlanc-Williams had created. It provides a written guide if you need it. There are lots of great details in here. Thank you, Melissa and Adafruit. I did stumble a bit when setting this up, so I've added additional context in here that I hope helps any newbies. I'll demonstrate the install on my Mac. Definitely consult the Learn Guide if you're not on a Mac and you run into problems. You can also ask questions on Adafruit's Discord. I'll show examples of the 3 most useful CircUp commands, but feel free to consult the Learn Guide if you want to learn more. Now, we'll use the terminal to install and use CircUp. Terminal is text-based. It doesn't have a nice graphical user interface, but CircUp is much faster and is so much better at making sure that your boards are updated that CircUp really is worth learning to use, even if you're a newbie. So we'll install using terminal. We can launch terminal on the Mac with Spotlight by pressing Command Space, then typing terminal, press return, and terminal will launch. Command plus will make the font larger if you need it. Command minus will shrink it. And in terminal, we enter the commands after the percentage sign and press return. To check if Python is installed and what version you've got, enter the command python3 space -- version, all lowercase, press return. Either you'll get a message you don't have Python installed, or you'll get the version number. Head to python.org and click download, and if this number is larger than your Python's number, you can upgrade. Just download and open the file on your computer and follow the install instructions. I just installed Python for the upgrade, and as a pro tip, you can repeat the last command that you entered in the terminal by pressing the up arrow key on the keyboard, press return to execute version again. One weird thing that you might notice, even though I installed a later version, I'm not showing that in the terminal, but if you just quit the terminal, get back in, and retype this command, you should see the updated version. Now, all Mac users should have Git installed, and you shouldn't have to worry about upgrading Git, but if you're curious, you can check with the terminal command git space -- version and press return. Next, we have to make sure that we have pip3 installed. Pip3 is a program that installs other programs. Now, Python should have installed it. We can verify this and upgrade pip3 if we need to. You should enter pip3, that's PIP3, space install, space -- upgrade, space pip, all lowercase, press return. My messages say that it's uninstalling and then installing a new version of pip. If you needed pip 3, you'll see install messages while it's installing. Now, most of the stuff that you see in the output isn't going to make any sense, but it's a good idea to look through the output, especially if you see anything in green or red. Those commands should be easier to read, and you might get some information that you need to install additional components or do some additional things before the install can work properly. And again, if you're on Windows, check the Adafruit Learn Guide for CircUp to see if these instructions differ for you. Next, we have to make sure that pip 3 setup tools are installed, and to do that, enter pip3 space install space setup tools. Setup tools is one word. Press return. They're likely installed, but if not, you'll see some install messages. And now we're ready to install CircUp. And to do this, enter the command pip3 space install space CircUp. Remember, that's CIRCUP, all lowercase. Press return. The install should work fine. To verify this, we could type in CircUp space -- version and press return. You should see that CircUp is installed. If not, you can quit the terminal and open the terminal back up, retype this command. You should then see CircUp is installed. And if for some reason that doesn't work, sometimes it requires you to restart your computer. But unless you got some kind of error messages, CircUp should be installed and you shouldn't need to do that again. If not, try repeating all the installation steps that we previously did and restarting your computer one more time. If you got here, congratulations, you've just installed CircUp, and you shouldn't have to repeat these steps again. Now, to show you CircUp in action and prove to you that it is installing libraries on our CircuitPy board's LIB folder, I'm going to open my CircuitPy board and open the LIB folder. It's currently empty, so let's get back into terminal so we can use CircUp. Remember, on the Mac, that's Command Space to bring up Spotlight. Type terminal, press return, and I'm going to resize things so you can see my screen and the Finder window. And then this is the command we're going to enter. CircUp space install space -a, press return to initiate the awesomeness. And what's happening here is CircUp looks inside the code.py file on your board, that's in CircuitPy, and remember the import NeoPixel statement in that code.py file said we need to import the library named NeoPixel. Now when it says searching for dependencies for NeoPixel, it's looking for any additional files that are required, and it finds this one called Adafruit_pixel_buff. So it installs both of those guys. And behold the majesty in your LIB folder that was previously empty. Now it has both these libraries automatically installed based on one simple command. You didn't even have to know what you needed. Fantastic. Now let's check out that sample code. And hey, if you didn't notice, if you look over at our Pico, our code is running, our lights are flashing. Now this code started running automatically as soon as the library files were copied over by CircUp, and if I wanted to restart this, I could unplug my board, plug it back in, and when I do this, code.py will run from scratch. We didn't have to do that, but I wanted to point out that if you unplug and plug your board back in, CircuitPy will restart from the start. Very nice. Now before we finish this lesson, I do want to show you two more CircUp commands that are going to be very helpful to you. This first command will let us install libraries one at a time, because sometimes you know what library you want to install before you write your code.py file. The command is just CircUp install and the name of your library. In each tutorial I should mention the name of any libraries you need, but you can usually find the name of the library that you need in the Learn Guide for that product at adafruit.com. So here I'm installing the library for the VL5131X distance sensor. Again, not a very friendly name, but we're going to be using this in a future lecture. Now I'll remind you in this lesson, but this Learn Guide tells me that my LIB folder needs to have Adafruit bus device. That's going to be installed automatically. When we install, this is the one we need, Adafruit_VL53L1X. You don't use the .mpy for the library name, just the part before the dot. You don't need to install this now, but feel free to try the command if you want. It's just CircUp install, and again, the name of the sensor's library. That's Adafruit_VL53L1X, all lowercase. Press return, and the terminal shows that it's installed, and I can see the new library in my CircuitPy board's lib folder. And in fact, you can see that this also required the installation of Adafruit_bus_device. Over here, we can see it required an installation of a whole folder. It's in there, and CircUp installed that too. Nice. Now this last example is for updating any libraries in your board's LIB folder, replacing them with newer versions if available. Now CircUp won't upgrade your CircuitPython version. You still have to go through the steps that we showed in an earlier lesson, where you visit circuitpython.org, download the UF2 file for your board, put your board in bootloader mode, and drag the UF2 file onto your board. But once you've upgraded CircuitPython, CircUp will take care of making sure that all of the libraries are up to date too. It's a huge time saver and only takes one command. So to show you how to use this command, I have a board with old library files on it. They're from about a year and a half before I recorded this video. If you're new, you likely don't have a board with old files. You can just return to this part of the lesson when you want to upgrade the libraries on your board. But if you want to follow along, feel free to download a set of old libraries on the Google Drive at this URL and drag them into the LIB folder on your CircuitPy volume if you'd like. Now this window in the Finder is my CircuitPy board, and this is the LIB folder. And you can see the libraries here have old dates. Now, if you copy the files over, you might see today's date, not these old dates, but we can verify they are indeed old with this next command. Now I'm going to type in the command CircUp space list. You don't have to use this command, but it provides a nice summary of the modules or libraries that are in your board's LIB folder, the current version installed, and what the latest version is. So now let's go ahead and update all this with the command that you do want to use. This is CircUp space update space -- all lowercase, press return, and you can see all these modules are updated, and you can see the dates have changed over in the Finder. Nice. Now I've got one more important update. It seems a past update of macOS, and I have no idea if this is fixed by the time you watch this lesson, but that slows down writing to boards that are plugged into the USB. It slows it down by like 40 times what it used to be. Now it's still not too long, but one thing that I recommend to avoid any problems is if you want to unplug your CircuitPy board, select eject first and then wait for the board icon to disappear. Now on the Mac, you can eject the board one of two ways. One is that you can either right-click on the CircuitPy volume and select eject, or the other is you could just drag the CircuitPy volume into the trash. You see the trash icon turns into a big eject button, but if you do that either way, you should see the CircuitPy icon disappear, and when it disappears, then you can unplug your board. The problem is, sometimes if you unplug your board while the system is writing to the board, then that could wipe out what's on the board, and you'll have to reinstall your lib folder, and you might lose what's in your code.py file. So remember to be safe, always eject your board when you're done using it or when you want to unplug it and plug it back in. So hackers, you've now installed CircUp on your computer, so you should never have to do that again. You know the basic commands that are most useful. I've added one more command at the end of the crib sheet here, pip3 install -- upgrade CircUp. This upgrades the CircUp program if a new version is available, and that product is always being revised, so it's not a bad idea to run that before you run CircUp. And you are now ready to easily install and upgrade any CircuitPython libraries that your project needs. You are now most ready to continue to hack.